on this website. How do I get to 7? Chapter 6, test review answer key.
I'm not sure.
What happens if I go to here? Does it? No, it doesn't give me another option to go to 7. Well, is it stuff you can read? What is chapter 7?
Radical functions and rational exponents.
Okay, yeah, we can. That's stuff you can verbalize. So let's try to do some problems maybe at the end of that chapter. Some of your homework or something.
Okay.
Radicals and what did you say besides that?
Radical functions and rational exponents.
Okay. So do you know what this means?
No.
It's the same as the square root of 4.
Okay.
This means the cube root of 4. Important stuff about rational functions. Here's one of the most important ones. In other words, if I have a number like the square root of 200, in order to simplify it, I can make it the square root of 100 times the square root of 2. And then that becomes 10.
Okay.
Same with division. Square root of A over B equals square root of A over square root of B. I hate to go on because I'm not sure what degree of difficulty you're at this point with these. You want to find some?
Yeah, I'm trying to just look at the book and see.
But yeah, just look at the end of chapter 7.1 and let's do some exercises.
Okay. Okay, it'd be, let's see. Just find all the real square roots of each number.
Okay.
First one is 225.
Find the real square roots of that. Okay.
Yeah.
You know what that is? It's 15 squared. I don't know how they give you a technique for doing this, or
No.
well, let's do another one before I launch into how I think they want you to do these.
Okay.
In other words, I'm sorry, that's not 15 squared, that's 15. In other words, 15 times 15 equals 225. Therefore, the square root of 225 equals 15.
Okay. There's one, it's 49 thousandths, 0.0049.
Okay, yeah, that's why I wanted you to bring the problems, because I was doing way too easy of problems. Okay, so the key thing about looking at square roots of numbers that are between 0 and 1, they get bigger. they don't get smaller. If you take square roots of number greater than 1, they get smaller. But if you take the square root of 1/4, it's equal to 1/2. It gets bigger because 1/2 times 1/2 is equal to 1/4. So know that we're looking for a number that gets bigger.
Okay.
So 7 seems to be an appropriate place to start. What if I squared that? What would I get? If I just squared that, what would I get?
0.49.
Okay, so I need another 0 in there. Now if I square that, I'm going to have 2 zeros. In other words, it's going to be 0.0049. In other words, the way to always check is to multiply the number back by itself, and you get 49. Okay, what else you got?
-1 over 121.
Going to take the square root of that? So you want complex numbers? You've had complex numbers, right?
Yeah.
Okay, so let's look at this. Using those 2 rules I gave you, what can I turn this into?
Be 1 over 11.
Only there's an I. In other words, it's really the square root of -1 over the square root of 121. Square root of 121 is 11, but this is I. So you could say 1/11 I.
Okay.
Okay.
Last one is 64 over 169.
So what should we try here?
Square root now be 8 over 13.
Yep. Because it's the square root of 64 over the square root of 169. Okay. I think you got that down. What else you got in the way of this chapter?
Next would be find all the real cube roots.
Okay.
And it's
So
different
this is cube root, same as taking it to the 1/3 exponent.
Okay. The first one's -64.
So what number, when multiplied by itself 3 times, is equal to -64?
4? -4?
-4. Notice that when you're taking cube roots, you can take the cube root of a negative number, because only -4 times itself 3 times is still equal to -64. It doesn't bring in imaginary numbers. And yet the cube root of 64 is equal to +4. So there's none of that plus or minus business either. And that is the way it is with all odd roots. In other words, the 5th root of 64 is, well, the 5th root of -32 is -2. It's only even roots that have to be positive numbers, or else you get imaginary numbers.
Okay.
What else?
Next one will be cube root of 0.125.
Okay.
0.5?
Well, 0.5 times 0.5 would be 0.25 times another 0.5 would be, yes, 0.125. Whoops, what did I do? 0.5, excuse me. I got lost in all the fives that were on here. Again, we're taking the cube root of a number between 0 and 1, and it's getting bigger. So whether you take square roots or cube roots or fourth roots, if you take that of numbers between 0 and 1, they get bigger. If you take it of numbers over 1, they get smaller. So what makes 1 one of the most important numbers in math. It's the balance point for a lot of things.
What about when it's like it's 27 over 216?
Well, again, we can make that the cube root of 27 over the cube root of 216, and those happen to be perfect cube numbers. What's the cube root of 27?
3?
And take a wild guess at 216. It's not 4, it's not 5, but it is a whole number, and it's small. 6 times 6 is 36, times 6 is 216. So that is equal to 1/2. Seems odd, doesn't it? That the cube root of that ratio would be equal to 1/2. But it is.
Last one is cube root of 0.000343.
Like that?
Yeah.
Enough zeros? Okay, so let's focus on figuring out the cube root of that. If the cube root of 216 was 6, what do you suppose the cube root of 343 is?
3?
7.
7? Okay.
Because 7 times 7 is 49, times another 7 is 343. Okay, so we know the answer is 7. Now the question is, let's figure out our decimal point. Well, it's probably not going to be 0.7, because that times 0.7 would be 0.49 times another 0.7. It's still going to be a number like 0.343. So that's doesn't work, but there's so many there's all we have to do is add 1 0 to it, and then we're going to have 2 zeros there, and then we're going to have 3 zeros down there. So 0.07 is it. Best way to tell is when you do these is whatever answer you get, multiply it together 3 times and see if you get this number. If you're allowed to use, of course you're not going to be allowed to use your calculator, I would imagine, on these. Just because it would take all the fun out of it. Okay? What do you got beyond cube roots? What does this mean? Or what is that? Well, what does it mean also?
It'll be the same as taking the cube root.
It's the same as taking the cube root of 8 squared. And when you do these problems, always do the denominator first. It'll make the math so much easier. In other words, the cube root of 8 is 2, and then 2 squared is 4. So the answer is 4, which is easier than squaring 8 first and then taking the cube root of 64. And you'll get a lot of problems kind of like this. How about this?
Nine?
Yeah. Do you have any like that in this chapter that have exponents that are fractions?
I don't see any.
No? Okay, well maybe not quite there yet. You'll get there.
Yeah. What about when it says simplify each radical expression? N is an even number, and it's using n as like an exponent.
Okay.
The first one is m to the n, with the n root.
Like this?
Yeah.
Okay. When you take the nth root of m to the n, that's the same as writing it like this. Because this is the root, and this is what you're doing to it, exponentially. So when I wrote 8 to the 2/3, I was taking the cube root and squaring 8. So when this letter matches the root, it's always 1.
Okay. So how is that simplified, though?
It equals m. In other words,
We don't do anything else with that?
no. Well, we don't know n, so, but
Yeah.
that's equal to m to the 1. We don't need the 1. No matter what m is, and no matter what n is, this is equal to m.
Okay.
And let me give you one. I came up with one the other day that was useful. Do that one on your calculator, if you have it handy.
$5.95.
You mean 4.95?
Nope. 5.95.
Okay. What should that be? Is this not the same thing as the square root of 25?
I'm not sure.
Well, yes, it is. In other words, it works both ways. Not only can I say the square root of a over b is the square root of a over the square root of b, but I can go the other way also. So the square root of 50 divided by the square root of 2 is the same as the square root of 50 divided by 2, which is the square root of 25, which is 5. Now, the only reason I said do it on your calculator is because it's going to have some round-off error when it does it. If you put in square root of 50 divided by square root of 2, I don't know what my calculator would give me, but I would expect something like 0.0001 or 4.999, just because I would think there'd be a little round-off error. The only reason I mentioned it is because you don't need that round-off error if you divide those two numbers first to make it into the square root of 25. You got any others that have variables? Those tend to be harder.
Yeah, you y to the 20th with your fifth root.
Okay, so how can I rewrite that? Using my exponents. Where's the 20 go? Where's the 5 go? Which one is the numerator?
The 20.
Notice y to the 4th works. If I have y to the 4th times y to the 4th times y to the 4th times y to the 4th, we're going to add all the exponents and get y to the 20th.
Okay.
So that's what the fifth root means, is that whatever our answer is, we're going to multiply it by itself 5 times to get that. Now, the other way to do that, obviously, is to just take out, in other words, the difficult question would be this one. What is that equal to?
Y to the 21st over 5.
Right, but we wouldn't want to express it as that. In other words, what this would be this. The fifth root of y to the 20th times the fifth root of y to the 1. Right? That's all I'm doing is separating it. And the reason I separate it is because that comes out as a whole number. Y to the 4th times the fifth root of y. That's the answer.
Okay.
I guess you could say y to the 21 over 5. That's also the answer. Just kind of depends on how your teacher wants these simplified. Usually this is how they want the answers, because they give you the problem like this, using a radical sign, so they want the answer using the radical sign. And more typical problems that you would get would be, tell me what this is. In radical form.
I'm not sure.
Well, let's separate it into 2. In other words, let's take the cube root of x to the 3rd times the cube root of x squared. And then this is equal to just x. And I still have the cube root of x squared left over.
Okay.
So that's what you do when you're taking these roots of variables. You take as many of the whole ones out as you can get. Is this a degree of difficulty you've covered or not?
Well, we haven't covered any of this yet because we just took a test today.
Oh, okay. All right. Well, this should help getting a head start on it. How do you think you did on the test?
Decent.
Decent? Good. So things are getting better?
some of it. Some of it still. I go to take the test and I have no idea how to do any of it.
Really? 'Cause it feels to me like
Yeah.
you get it most of the time.
Yeah.
We just got to make sure we cover all the material you're going to get tested on.
Mm-hmm.
So, but I got to believe that it helps if you get a little ahead of it also.
Right.
Whenever the teacher does go to cover this material, it should, you should be able to absorb it easier, I would think. All right. I think your next appointment is next Monday.
Okay.
I will talk to you then. Have a good week.
Okay.
All right. Bye-bye.